So by now you should know that when a node on the network is the first to solve a mathematical equation, it gets to add a block to the blockchain. In this video, we're going to get more information about this equation. And to do this, we have to learn about cryptography. Now, cryptography serves a very important purpose in Bitcoin. As a matter of fact, without it, Bitcoin would not exist. So what is it? Cryptography is the study of secure communications. So if you are sending a message from one place to the other and you don't want anybody to be able to read that message, you will encrypt that message. There are many different forms of encryption, and human beings have been encrypting messages for hundreds of years. One of the simplest encryption techniques is known as Caesar cipher. In the Caesar cipher, you replace one letter with another letter some fixed number of positions away in the alphabet. The fixed number of positions is called a key. So if you have a word like boy and a key of 3, the encrypted version will be ERB, because we're shifting each letter by 3. The encrypted text is known as ciphertext, and the unencrypted text is known as plain text. And the rules by which messages get encrypted is called an encryption algorithm. Now, Caesar cipher is a very simple algorithm with a simple key, but the basic concept is the same. Based on a set of rules and a key, you can lock and unlock a message. Now, there are two different types of encryption algorithms: symmetric and asymmetric. Now, symmetric encryption is sometimes referred to as a shared key because both the person that sends the message and the person that receives the message needs to have the same key. So, in the Caesar cipher example above is an example of a symmetric encryption, because in order for somebody to decrypt the ciphertext, they would need to know that the key is 3. In asymmetric encryption, every node will have a pair of keys, a private key and a public key. The private key, as the name suggests, is only accessible to the owner, and the public key is available to everybody. If a message is encrypted with a private key, only that node's public key can decrypt it, and vice versa. So if John wants to send an encrypted message to Mary, and only Mary, he would encrypt his message with Mary's public key. And since only Mary's private key can decrypt that message, John will be able to securely send the message to Mary. Asymmetric algorithms are a key part of digital signatures. A digital signature is a way of proving the authenticity of a message. So if I send a message and I want to prove that it is real and it's from me, I'll just sign the message with a digital signature. And how that is done is, I would encrypt the message with my private key, and since my public key is available to everybody, if anybody wants to prove that I am the sender, all they need to do is use my public key, and they will prove that it was sent by me. There's one more concept you need to learn about from this video: hash functions. A hash function is used to map any size data to a fixed size. If you take a 3-letter word like boy and run it through a hash function, it will give you a fixed size encrypted output. If you take a 30-word sentence and run it through the same hash function, it will give you a different hashed output of the same length as the hash output from boy. The difference between a hash function and an encryption algorithm is that a hash function is irreversible. You cannot take a hash and determine the initial input. It is used to prove integrity of a message. So if you take a message and hash it and send it to someone, if someone else wants to prove that the message they're looking at is exactly the one you sent and nothing has been changed, they will just hash the message and look to see if they got the same hash value. Hash functions and digital signatures are key components of Bitcoin mining, and they will come up again in the next video.